Hi everyone, I'm Song, and I recently joined the UCF in the last fall semester, Department of CS and Institute of AI. Um, so maybe a brief introduction. I got my PhD degree from the University of Virginia, and this is my contact. And recently, I'm teaching the course applied machine learning, and I'm very interested in teaching at the intersection of machine learning, data science, and biomedical AI. Um, so talking about my research overview, I think my core research theme is uh, integrative and interpretable multimodal AI systems in healthcare and bioinformatics. So these are my major area of focus. For example, the multimodal learning, which is to integrate multiple data modalities such as genomics, image data, clinical data, any type of data, and incorporate them together to perform some analysis. And also the multi-agent frameworks. Here we use specialized agents that can collaborate and resolve conflicts by discussing with each other. And here each agent can be a large language models or small models. So any models can be an agent in our framework. And I also focused on the trustworthy AI, interpretable AI. That means we have tried to, for example, focus on the concept-based reasoning, which is to increase the interpretability of large language models using the concepts, human understandable concepts. And also the robustness under the data shift. That means if the training data or the input data has some different distributions, our models can still deal with this scenario. So these are some very general areas of focus, and maybe I can briefly go through our previous works on, for example, the interpretable concept learning, and are some previous works that we want to increase the interpretability of the large language models by using the concepts. For example, the concepts of this sentiment analysis task can be like, for example, the food, the ambience, the service of this restaurant, and so that the output of these large language models can be understood by the humans. And so, for example, this comment is good because for example, they have a high review for the food and on the service. So these are some of our previous works on the interpretable learning, and I also focused on the multi-agent systems. For example, these are some of these systems we designed for multiple agents to interact and discuss with each other, and these agents can have different roles. So, for example, in a coding task, the agents can be a programmer, a project manager, or any related roles. And in the medical domain, these agents can be different specialists, the cardiologist, the oncologist, something like this. And these agents can communicate with each other and discuss. Then we use this kind of the judgment, LLM judgment, and the multi-agent debate to further increase the factuality of these agents. And so this is, for example, to use LLM to decide whether this discussion can lead to a reasonable output, something like this. Yeah. So this is like our design for the multi-agent systems. And what can we do with these interpretable learning and multi-agent systems? So for example, here I can introduce a specific application in the Alzheimer's disease because I'm very interested in all these, for example, aging related disease and any disease like the dementia related disease. Yeah. And for example, current medical LMs, they typically focus on one or two modalities like HR and image. But the question is, how can we learn from and integrate this multimodal data? For example, in the medical institution, we have this medical image data, text data, speech data, even the genetic information data, and these different kind of signals. And our task is to integrate all these different data modalities and using some techniques so that this all data can be used for a specific that the medical diagnosis, for example. Um, but of course, medical diagnosis is only one of the downstream tasks. We can also conduct many other different tasks. Maybe I can introduce this later. Yeah. But these are some diagnoses that we can conduct with the multimodal data. And for example, for this AD Alzheimer's disease diagnosis, we have this multimodal framework. Here we have, for example, three modalities: the PET image, the MRI images, and the demographics of the patients, right? And with these different modalities, we use a modality gating net and a region gating net, and this net can incorporate multiple experts, and each expert is a smaller model that focuses on a specific region. For example, in this PET expert, the one expert focuses on the frontal lobe, and another expert focuses on this another lobe. And so all these different experts can focus on different regions of the human brains. And so that after we learn the for example, the limitations of these different regions, and we will aggregate them together alongside the expert of the demographics, right? And with all integration from all these different experts, we can finally get a final diagnosis, which is a classification from these three classes. AD means the patient is diagnosed as the Alzheimer's disease, and the other CN and MCI means that they do not show the much signals of the disease. So this is a simple framework that we can use to integrate different data modalities, right? And also for this is like the illustration of the results. Because we use the different experts for different regions of the human brains, and so we can use the learning output from these experts to plot these kind of importance plot. This shows that for the Alzheimer's disease, the experts in these regions are more important, and this can provide some insights on, for example, what brain regions can potentially lead to the diagnosis of the Alzheimer's disease. So this is like a illustrative example. And for the multi-agent interpretations, remember that for the expert, it's only a very small model, right? But we want to utilize the current large language models that can provide additional interpretations, right? And so we can use the outputs from the previous experts. We input all these experts into our framework, and these get-driven LLMs, and we use multiple LLMs, and they can frame this overview framework, and these different agents will use the information from experts and will discuss it with each other, and finally there will be a moderator agent to integrate all these outputs from these agents and provide a final diagnosis. And with this diagnosis, we can also provide the interpretations. So these are the more important. For example, all these agents, they can provide some diagnosis, but they may not reach a consensus, right? Their diagnosis can be different, and we finally use the moderator to get a final conclusion, the diagnosis of AD, and also they can provide some interpretations about how these agents can reason and lead to this conclusion, right? So this is like what the moderator does, and to provide additional interpretations. So this is the benefits of incorporating these LLMs in the multi-agent framework, because these LLMs can provide the text output so that they can provide the additional interpretability, and this can be also very important. Yeah. So talking about the future, my future is like to bridge the gaps between the LLMs, the multi-agent systems, and the general AI, and the healthcare. So I am to apply my research works to the applications of the healthcare. But of course, this is still a very difficult domain. So I think there are so many problems that remain to be solved. For example, the first, more multimodal data. We know that currently the models are very good at, for example, the processing the text data, image data, right? So these ChatGPT, Gemini models, they are very good at this kind of data. However, if we incorporate more data from other modalities, such as the audio data, video data, and even gate data, right? The models are not very familiar with this type of data, and if we directly use them to perform diagnosis, the results may not be very satisfactory. So my next step, the future direction will be that we want to incorporate more different data modalities so that we can use all this information for a better diagnosis of the patients. And second is the human in the loop for the prior knowledge. The LLMs and models are very powerful, but they may not have prior knowledge, right? This knowledge is actually stored in the brains of the doctors, right? So we want to incorporate this human in the loop design so that the doctors can participate in our framework to provide something like the doctor annotations or the validations of the clinical records, for example, and so that this we can use this domain knowledge to further refine our models for better performance. So this is also another direction, and this is like the third direction is to make LLM safer and prevent the privacy leakage. We know that to get a very good diagnosis model, right? We need to train this model on the data set collected from, for example, thousands of patients. And in this case, the model has learned this data, and but after we release this data, we release this model, some attackers they can extract the privacy of these patients from the models. So this is actually a very severe issue because these malicious attackers they can extract this individual information, and we need to design specific privacy leakage prevention techniques to prevent such privacy leakage. So this is also very promising direction because for example, the NIH they are focusing more and more in this safety and privacy issue of the current large language models and foundation models, right? Because people are just using all available data to train the model, and this can incorporate some very sensitive individual information. Sorry, so that's this about the bioinformatics discovery, and we also aim to promote this kind of discovery with our techniques, and so that this discovery can also help with the diagnosis of the healthcare. I have also conducted research in the domain, for example, the multi-omics, the spatial omics, something like this, and so that we can maybe the insights and discovery can also help with the healthcare applications. So these are my future research directions. I really look forward to collaborating with all different researchers from different domains, so that we can, for example, complement with each other's expertise. Yeah. So, and thank you. Do you have any questions?